Hello, welcome again to my continuous series of question answer sessions. Now, today we are going to deal with the circle theorem, and I'm going to be very brief on how to handle this problem in circle theorem. So I'll try to handle question one, and then I'll leave question two for you to handle. Now, I'm going to use technology to handle this particular problem. So let's look at some of the properties in circle theorem, and I'm going to be very brief on them. Now, I'm going to start with the first property here, where we have a triangle that moves to the center. You know, very simple. Now, I have this triangle here, and I have another triangle which is subtended to the circumference. So I'm using the word subtended to the circumference. So it can be at any point at the circumference here. So now, when we have such a situation, then we can say that a student can easily get the properties of the two triangles and the angles in them. So let's look at the angle at the center here. So the angle at the center here is 73.9. So for my case, I would like to make it maybe a whole. Let me make it something nice, maybe 80, and I would like to maybe 80.06, almost 80 degrees. Now I want to look at the angle at point D. So what happens at point D here? Now at point D, if I put that angle at point D here, it will tell me something. Now it tells me something. The angle at the center is 80.06, but the angle at the circumference here, is 40.03, which means it is half of the angle at the center. So how do we give the reason for this? So we say that the angle subtended by the chord, you see, chord is BC here, or the arc BC, which is the minor arc, to the center, the angle at the center here is twice the angle at subtended by the same chord or arc to the circumference. So the angle at the center is twice, but subtended by the same chord is twice the angle subtended by the same chord to the circumference. So that one is very important and very easy. So if I have 100 at the center, then the angle at the circumference is 50, as long as the angle is subtended by the same chord. Now I go to the second one. If I have the angle subtended by the same chord, all of them to the circumference. Now look at this. Now I have another angle here, but now moving to the circumference. Now I have two triangles which are subtended by the same chord to the circumference. Look at the first one here, which we got 40.3. What will be this angle at point E? So if we find the angle at point E, then it will give us another property. So what is this angle at point E? At point E, the angle is 40.03. What does it tell you? These two angles are equal. Then what are the reasons? You say that angles subtended by the same chord to the circumference are all equal. So therefore, we can say that whatever you do here, we can play around with this. Whatever you do here, the angles remain the same. So whatever angle you draw these triangles, the angle you can see remains the same. You see, the angles don't change. So even if we draw another one at this point, the angles don't change. So angles subtended by the same chord or arc to the circumference are equal. What is the third one we talked about? We talked about the angles in a semicircle. So very first, we draw a diameter, which versus a diameter, which is I want my diameter to go there and then back here, or just let me just have a different. Let me have my diameter as usual there. Then I want to make it different, so it has to pass through the center there. Make sure that it passes through the center. Yeah, and then let me just have it at this point, just different points from the rest. So now this, I have my diameter is BAF. You see, BAF is my diameter. So what will be the angle at the center here? We just know that the angle at the center here is 180. So which means the angle at the circumference should automatically give you 90. But let us confirm, what do we get when we are talking about the angles in a semicircle? You see, the angles in a semicircle, which gives you here is, let us see it properly, which is 89.77, which is approximately 90 degrees. So it tells you that the angle subtended by the diameter, you see this is the diameter BAF to the circumference is equal to 90 degrees. So in approximation, so if I tell you to one decimal place, this one is equal to 90 degrees. Okay, this is equal to 90 degrees. So that is exactly what you are supposed to have. Finally, I can talk about angles in a cyclic quadrilateral. Now, angles in a cyclic quadrilateral means that when we are talking about quadrilateral means, and the student has to be very keen to see the four sides of the quadrilateral. Quadrilateral means four-sided. So you have to be very keen to see the four-sided figure. Now, what are the four-sided figure? We have B, we have H, we have I, and we have at point C. If you find the angle, this is now what you have to bring out. The angles, the following angles are very key. For instance, I've gotten that angle at H, 76.94. And then at the same time, I'm getting the angle at point C, which is 103. Let me put 103.06. Now, if you add the two angles, opposite angles in a cyclic quadrilateral, cyclic, it has to be four-sided. So the student must have a keen eye to see the two sides, okay, the two opposite sides. If you add the angles of the two opposite sides, that is H and C, you get 180 degrees. 180 degrees. Whether we try the other side here, it will still give you 180 degrees. So that is 77. And if we have this side, the whole of this side here, you can see 102.51, 77.49. It gives you 180 degrees. So this is simply the properties of angles in a circle. So finally, I'm going to talk about the tangent points. You see, I want to talk about the tangent at a point. So I have this tangent here that I have drawn. So this tangent here will tell us something. So having this tangent here, it is just very simple. We can see that we have the angle that is made by the tangent and the sector. You see, there is this segment, not sector, segment here, this segment. The sector is big here, but segment here, segment HB, you see there is this angle here. See? So I want to demonstrate this angle. We have an angle at this point. Just a minute. Angle here. You can see we have this angle. Okay. So this angle that we are getting here is important to us. So this is 37. You see, this is angle 37.46. Now, if you look at it properly, when you have this, when you have this angle, then you can easily find which angle is equal to this, or what kind of a characteristic that it displays. Now, also we can have this angle here. Let me have another angle at this particular point here. So I can have another angle here, which is angle that which is 40.03. Now look at this. Let me use this one. You look at this segment 40.03 here, and the segment is KC. You know, BC. This BC. You know, B. This angle at B, that is CBK or KBC. Angle is 40.3. Now look at this chord, which is BC. This triangle here, which is, you know, which the chord that moves from point B to C and then back to the point of the tangent here, it has an angle here, you know, and this angle is in the alternate segment. This is one segment here, this is minor segment, and the whole of this is the major segment. So this angle here, you can see, is equal to the angle in the alternate segment. So how easy is it for you to get this? The easiest way to get this is for you to look at the chord, which is BC. You see the chord, which is BC. So the angle that will be made at the point of the chord meeting the circumference and then back to the tangent point is equal. So the angle of that is at point B here, you know, is equal to the angle in the alternate segment. That is how you get the properties of angles in a circle. So in this case then, how do we get these angles? So for today, out of those properties that we have dealt with, I just want you to try the two questions. That is question 1 and then question 2. And then in the next video that I'm going to do, we are going to deal with an overall questions on angles in a circle, that is the circle theorem. I think with those explanations, it will make it easier for you to get this particular two questions here. Now, for instance, this one, I want you to look at the properties because it is easy. You can look at this angle at the center, then the angle at the circumference here will be half, which is 35. You know, just get it like that. These are two cyclic quadrilateral, these are opposite angles, you know, which the students can easily get, which totals 180. So you can see how easy the question is becoming. If this is 170, this is 110. This is a straight line. Okay. So if this is 110, so E becomes 55. 110. What is the remaining? We're remaining with 70. So this is 35 degrees. Okay, 35 degrees. So you can see that we are almost getting all the angles here. So can you get all the other angles? And also you try this question 2. So we shall continue in the subsequent series of question answer sessions. Thank you for today, and make sure that if you like this, make sure you like it and subscribe, and make comments for me to improve in the next videos.